In the last two lectures, we have discussed well-ordering principle, divisibility theory, properties of divisibility, division algorithm, GCD, properties of GCD, Euclidean algorithm for finding GCD, Diophantine equation, congruence, Fermat's theorem, Wilson's theorem. Linear Diophantine equation in two variables having integral coefficients is ax plus by equals c. Suppose that there are integers x0 and y0 such that ax0 plus by0 equal d, where GCD of a, b is d. Say this equation is 1. All integral solutions of equation 1 are given by x equals to x0 plus b by d k, y equals to y0 minus a by d k, where k is any integer. Congruence: a is congruent to b modulo m, where a and b are any two integers and m is positive integer. It means a minus b is divisible by m, or m divides a minus b. Example: 43 is congruent to 13 modulo 5. 43 minus 13, that is 30. 5 divides 30. Properties of congruence. Property 1. If a congruent to b modulo m, then b is congruent to a modulo m. Property 2. If a is congruent to b modulo m, then a modulo m equal b modulo m. Property 3. If a is congruent to b modulo m, then a plus minus c congruent to b plus minus c modulo m. Property 4. If a congruent to b modulo m, then AC congruent to BC modulo M. Property 5. If AC congruent to BC modulo M, then A congruent to B modulo M by GCD of C, M. Property 6. If A congruent to B modulo M and C congruent to D modulo M, then A plus minus C congruent to B plus minus D modulo M. Property 7. If A congruent to B modulo M and C congruent to D modulo M, then AC congruent to BD modulo M. Property 8. If A congruent to B modulo M, then A power n congruent to B power n modulo M, where n is a positive integer. Fermat's theorem states that if P be a prime and A is an integer such that P does not divide A, then A power P minus 1 congruent to 1 modulo P. Wilson's theorem states that if P be a prime, then P minus 1 factorial is congruent to minus 1 modulo P.